The third example for product rule is showcased in this video. Welcome to Differential Calculus. Let's recall a pattern of the product rule. Having two functions, f of x and g of x, we differentiate their product by copying the first term and differentiating the second term. Then add to this term the second term copied, multiplied by the derivative of the first term. The function for this example is y as the quantity of negative 7x raised to 4 plus 10 times x raised to 2/5 plus 8, multiplied by the binomial x squared plus 10. Let's differentiate the function with product rule first. According to the pattern, the derivative of y with respect to x is the first term multiplied by the derivative of the second term, plus the second term multiplied by the derivative of the first. Now that we identified which terms should be taken derivatives with, distribute d over dx to each of those terms. dy over dx is the first term multiplied by the derivative of x squared plus the derivative of 10. Now, add the second term with the distributed derivatives of the trinomial factor, that is, d over dx of negative 7x raised to 4 plus the derivative of 10x raised to 2/5 plus d over dx of 8. From here, reduce the derivative by zeroing out the derivatives of the constants 10 and 8. Then continue the solution by moving constants before d over dx. dy over dx then has the copied first term times d over dx of x squared. There is no coefficient to be placed out, plus the second term times the processed binomial. The first term has negative 7 placed apart from x raised to 4 and a constant 10 out of the term x raised to 2/5. Work further by using power rule. The derivative of x squared is 2x dx over dx. The derivative of x raised to 4 is 4x cubed dx over dx. And the derivative of x raised to 2/5 is 2/5 times x raised to negative 3 over 5 times dx over dx. Again, dx upon dx becomes 1. So the simplified raw derivative is the first term times 2x plus the second term times the quantity of negative 28x cubed plus 4x raised to negative 3/5. This is the derivative of the function, although we can still have it simplified through algebra. First is to distribute terms to eliminate parentheses. The derivative starts with negative 7x raised to 4 times 2x, which is negative 14x raised to 5, plus 10x raised to 2/5 times 2x, which turns out as 20x times x raised to 2/5, plus 8 times 2x, which is 16x. Using FOIL method for the second term, there are x squared times negative 28x cubed, giving 28x raised to 5. There is also x squared times 4x raised to negative 3/5, which is just coined for now as 4x squared times x raised to negative 3/5. Then, with a factor of 10, the next term is 10 times negative 28x cubed, giving negative 280x cubed, plus 10 times 4x, raised to negative 3/5, which is 40x raised to negative 3/5. Let's simplify the second term. With fractional exponents, it is easier to add them when they have the same denominator. So the equivalent fractional exponent of x is 5/5. Then 5/5 plus 2/5 is 7/5. So the second term now becomes plus 20x raised to 7/5. The fifth term can also be simplified similarly. X squared is taken as x raised to 10/5. Then add negative 3/5 to end up with plus 4x raised to 7/5. With this, the derivative has been simplified, and all we needed to do now is to collect similar terms. dy over dx then takes negative 14x raised to 5 minus 28x raised to 5, making negative 42x raised to 5. There are also two terms with x raised to 7/5, and their coefficients are 20 plus 4, resulting to 24x raised to 7/5. The rest of the terms are just copied. They are 16x minus 280x cubed plus 40x raised to negative 3/5. This is the final derivative. The alternate solution uses power rule right after the function is simplified into individual terms. So take out groupings first by multiplying terms. Y is then simplified with negative 7x raised to 4 times x squared as negative 7x raised to 6. 10x raised to 2/5 times x squared as just combined 10x raised to 2/5 with x squared. Then 8 times x squared is 8x squared. With 10 as the next factor, the succeeding terms start with negative 7x raised to 4 times 10, making negative 70x raised to 4. 10x raised to 2/5 times 10 is 100x raised to 2/5. And lastly, 8 times 10 is 80. Simplify the second term by equivalent fractions. X squared is x raised to 10/5. Then adding exponents, we get 10x raised to 12/5. So the function is already simplified, and we can differentiate it from here on. Distribute d over dx to each term in the function. Then note that d over dx of 80 is just 0. Next is to move all constants before the derivatives. So dy over dx becomes negative 7 times d over dx of x raised to 6 plus 10 times d over dx of x raised to 12/5, and also 8 times d over dx of x squared, followed by negative 70 times d over dx of x raised to 4. And the last term is converted to 100 times d over dx of x raised to 2/5. With the constants out and individual x's are to be derived, we employ power rule. The derivative of x raised to 6 is 6x raised to 5 dx all over dx. The derivative of x raised to 12/5 is 12/5 times x raised to 7/5 with dx upon dx. The derivative of x squared is 2x times dx all over dx. Then the next term has the derivative of x raised to 4, which is 4x cubed with dx upon dx. The last term looks for the derivative of x raised to 2/5, which is 2/5 times x raised to negative 3/5 times dx over dx. All dx over dx cancels out, providing the final answer of negative 42x raised to 5 plus 24x raised to 7/5 plus 16x minus 280x cubed plus 40x raised to negative 3/5